Susan, and I'm from Department of Economics of Cornell, and my advisor is Professor John Conrad. Hopefully that this work can be part of my dissertation. So the Endangered Species Act was passed by the Congress in 1973, and the main purpose is to protect and recover the endangered species and the threatened species. Also, this act also requires the conservation of the habitat that the species rely on. So when listed under the Act, the Endangered Species Act, a recovery plan is required to specify what's the timeline and what's the program, what's the steps to help to recover the species in question. So a natural question to ask is that when we design this recovery plan, what's the optimal time that we should come up with that we can start the actions, the conservation actions? So an obvious answer or intuitive answer is now. If a species is threatened or endangered, then we should save it now. However, there are many species whose population is declining, and actually a more careful answer should be that it depends on many variables, many parameters, such as how fast it is declining, how varied the population is, what's the hazard rate, and how much does it cost to save them, and how valuable the species is, and how effective the actions are. So what I want to study is to adapt the model of Kahn and Stinchcomb 1915 paper, the hesitation model, to design a hazard rate model to derive the first order condition and the second order condition to find optimal condition of the best timing to start the conservation actions. The hazard rate is derived from a stochastic population model for endangered species from the paper of Dennis, Mulholland, and Scott in 1991. And I use two examples, California condor and whooping cranes, as the two examples to illustrate this method. Although this method is actually intended for the species that hasn't really started the conservation actions yet. Both California condors and whooping cranes, the conservation actions were started way earlier than recently, so, but I still use these two as examples to illustrate the method. Okay, so I think that's all. Thank you.